This video is about exponent. Exponent helps you to write a long multiplication in a more compact form. Before we start, exponent has two other names. So other than exponent, sometimes we use the word power. Sometimes we use the word degree. Right? So just three different names, but most of the time in statistics, we use the word exponent and we use the word power. Okay, so base and exponent, repeated multiplication of the same factor can be written in two ways. So either you have a base, x is the base, and then n is the exponent. So if you think that is too much for you, so let's say I have x raised to a 2. So the way we read this is x raised to the second power. So that means you have x multiplied by itself 2 times. If you have x raised to the third power, you have x multiplied by itself 3 times. Let's say you have y raised to the fourth power, then you multiply y by itself 4 times. But if you have let's say a raised to the 25th power, then you have to write a times a times a times a 25 times. So which one do you prefer to write, a raised to a 25 or you write 25 copies of a? So this one we have a multiplication of 25 copies of a. So just a number multiplied by itself 25 times. So using exponent, we can write the expression in a more compact form. So there are two more words that you have to use. The first one is a square. Square means second power. So this is a square, second power, and then the third power, we call it a cube. The fourth, the fifth, we don't have a specific name for that. So anything higher than 3, we just call that x, y raised to the fourth power, the fifth power, the sixth power. But for second power, we call that a square. For third power, we call that a cube. All right, so this one is x raised to the n. That means I have x multiplied by itself n times. So on this side, we have n copies. N copies of x multiplied together. All right, so let's take a look at this problem. Writing exponential form. Let's put this problem up. Write in the exponential form. Do not write the expression in exponential form. Do not calculate the exact value. So all you have to do is count the number of copies. So for 3, how many copies do we have? We have 2. So a, we have 3 to the second power, and then 7 we have 1 2 3 4 5 6 7 8. So that will be times 7 raised to the 8th power, and then multiply -5, the entire -5 in parentheses, raised to the third power. The parenthesis is necessary. You will need the parenthesis because that change a lot of things. And then the next one, a, we have 3 copies of a, so that will be 8 to the third power, 1 copy of B, 2 copies of C, and then 5 copies of D. So the dot means multiplication. All right, so let's put this on the actual number. So I want you to evaluate this. The square of 5. So the square of 5, we have 5 square, right? So 5 square is equals to 25. And then the cube of 5, so 5 to the third power, so that is 5 times 5 times 5, right? So 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. This 5 square is the same thing as 5 times 5. And then we have -2 square, right? So the entire -2 square. So that is -2 times -2. That equals to 4. And then we have -2 to the third power, so that is -2 multiplied by itself 3 times. So -2 times -2 is 4. 4 times -2 is -8. And then we have -2 to the fourth power. So that is a -2, -2, -2, -2. So since they are all multiplication, that gives me a 4. And then that gives me a 4. So we have 4 times 4 equals to 16. How about the one without parenthesis? Let's switch color for that. So if we have -2 raised to the second power. So what is that means? That means when there is no parenthesis, the -1, the exponent, this exponent, does not belong to the negative sign. So basically this one is really a -1 times 2 square. So this is one multiplication. 2 times 2 is equals to 4. 4, and then you multiply by that -1, that is equals to -4. All right. So although it looks like you multiply two negative, but without the parenthesis, then the two, the negative sign has nothing to do with the exponent. And then -2 raised to the third, so the -1 stands by itself, and then 2 times 2 times 2. So we have 2 times 2 is 4, 4 times 2 is 8, then we have a -8. And then we have -2 raised to the 4, so that is -1, 2, 2, 2, 2, right? So that will be a -16. And then we have fractions. 2 over 3 raised to the 4th, so that is 2 times 3. Without parenthesis, we don't really, without negative, we don't need the parenthesis. 2 third, 2 third, right? 2 third, 2 third. So numerator times numerator, denominator times denominator. So a compact form is 2 raised to the 4th, and then 3 raised to the 4th, right? So the top is 16. And then the bottom. So most people will just do this in your calculator, right? Let's do one by hand and let's do one by a calculator. So 3 raised to the 4, so 3, 3, 3, 3, right? So that gives me a 9. That gives me a 9. 9 times 9 is equals to 81. What if I am lazy? I don't want to do this by myself. I want to count on my calculator. Okay, so if you do this in your calculator, you type the base first. You type the base first, and then somewhere in your calculator there must be a key that helps you to raise to n power. So it's like typing a superscript, right? So there must be a key that looks like this, like a triangle without a base. So when you type this key, you will see that the cursor will raise to the upper right hand corner of 3. So that is raised to a certain power, and then you type a 4, that gives you a 81. Okay, and then what about negative? Negative, so we have -2 third raised to the third, so -2 third. This one we do have to use parenthesis. Negative times negative is positive, positive times negative, so we have negative anyway. 3 times 3 is 9, 9 times 3 is 27, or you write 3 to the third power, and then the top is 2 to the third power. So that the top is 8, that the bottom is 27. All right, the last one, 2 raised to the third, and then 5 raised to a square, so that is 2 times 2 times 2. 5 times 5, the bottom is 25, the top is 8. All right, so that's how the exponent works. You will see exponent, the power. This one you can call it the third power, the second power. So they are exponent, or in algebra, we call it a degree. Other than that, you will also see negative exponent in statistics. So negative exponent, let me switch color again. So negative exponent. So negative exponent, so let's say I have a base and then raised to a negative power. So this is 1 divided by, always 1 divided by a, and then you remove the negative. So the way I interpret this is I toss everything to the bottom and then remove the negative. The top is just 1. So let's say you have 2 to the -4. So you have 1 divided by 2 to the 4. So 2 to the 4 is 16, right? So 1 over 16. And then what if you have 1 divided by 4 to the -2? So that will be a complex fraction. So in the denominator, you have to build another fraction. So that will be 1 divided by 4 square. 4 times 4 is 16, right? 1 divided by 1 over 16. So that will be the top multiply, the reciprocal of the denominator. So at the end, you have a 16. All right. How about this? How about I have 1.5 times times 10 to the -5. So that will be 1.5 times 10 to the negative 5, so that will be 1 divided by 10, you raise to the fifth, right? So 10 raised to the fifth is simply 1 followed by 5 zeros. 50. So you have 1.5 divided by 1 followed by 50. So that means you have to move the decimal point 5 steps to the left. So this is how I do it. I draw 1.5 and then I prepare a few zeros and then I start the move. 1, 2, 3, 4, 5, 5 step. So that is equals to 0.0004015. So basically, when you see a problem like this, that means this quantity is very, very small. So that will be all in this lesson. If you think my lesson is helpful to your learning, subscribe, like, share the video out for me. I appreciate your help really much. I see you all in the next lesson.